Okay, let's continue our discussion with this idea of quadrantal angles. A quadrantal angle is an angle in standard position whose terminal side lies on an axis. The measure of a quadrantal angle is always a multiple of 90 or pi halves radians. Let's look at an example. And remember, we're going to look at these in the frame of the unit circle. So let's pick here our first quadrantal angle pi halves or 90 degrees. In the previous lesson, we discussed how sine of theta equals y over r, which with a radius of 1, as all triangles are, it just ends up being y. So sine of theta equates to our y value. Well, what would our, and of course, if I were to label this, this point here would be 0, 1. And that's an x, y. Okay, so let's do sine here of pi halves or 90 degrees. Pi halves, let's use. Okay. Well, what's my y value? My y value is 1 at that location. My radius is always 1, so 1 over 1 equals 1. How about the cosine? Well, the cosine, remember, we said was y over r, which would be x over r, which again would be x over beep, beep, delete, 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 x over r, which would be x over 1, which would just be x. Okay? So let's do the cosine of pi halves here. Cosine of pi halves. Well, what's my x value at pi halves? 0. What's my radius? 1 equals 0 over 1 is 0. So the cosine of pi halves would be 0. Okay, let's go further. Tangent of theta, we said on the unit circle, would just be sine of theta over the cosine of theta. And if sine is y and cosine is x, we can further simplify. Okay, tangent of pi halves. Well, what did we say sine of pi halves was? Well, we said it was 1. And it's also y here. Okay. And how about the cosine of pi halves? Well, we said that corresponded to x, and also it came out to be 0. What is the value of 1 over 0? We've got an undefined quality. So we're going to write undefined, right? That's previously where we had an asymptote, right? Okay, let's just go ahead and construct our remaining ones. Cosecant. Cosecant of pi halves is paired with sine. And it would just be sine flipped over. 1 over 1 flipped over is 1. How about secant of pi halves? Well, secant of pi halves would just be cosine flipped over. Cosine was 0 over 1. Let's flip it over. 1 over 0. We've got to write as what again? Undefined. And let's do cotangent of theta, pi halves. Well, that's just tangent flipped over. 1 over 0 becomes 0 over 1. 0 over 1 is 0. So, we just evaluated our 6 trig functions for a quadrantal angle, in this case pi halves. The other quadrantal angles, of course, are pi, and that's 180 degrees. 3 pi halves, which would be 270 degrees, or 2 pi, or 360 degrees, also known as 0. 2 pi or 360 degrees. And these are all what's called quadrantal angles because they're on the quadrants. And notice we have 4 quadrants, our axes divided into 4 pieces. Okay, let's look at another. I'm going to do this one a little over to the side to give myself a little more room on this right side to show what, as we construct our 6 trig functions. Okay. All right, so maybe we want to find out all of our 6 trig functions of this location over here, which happens to be pi, also known as 180 degrees. Okay, in that location on the unit circle, since we have a radius of 1, would be -1 on x and 0 on y. X, comma, y. It's going to help to label these values before we start constructing. Okay, and I'll again put quadrantal angles. Sine of theta we said was y over r, which is just y over 1. So let's do sine now of pi. Well, what's my y value? 0. What's my radius? 1. Sine of pi is 0. Okay, we've done 1. Cosine. X over r, which is just x over 1. Let's do the cosine of pi. What's my x value? -1 over 1, which is just -1. Tangent, we said, is sine over cosine. And also y over x. Well, what's my y value? 0. What's my x value? -1. 0 over -1 is 0. Okay, let's do our reciprocal functions. Cosecant of pi would just be sine of pi flipped over. Well, 0 over 1 flipped over is 1 over 0. Uh-oh, that's what? You got it, undefined. How about secant of theta? I'm sorry, secant of pi. Well, secant of pi is just cosine flipped over. Well, what's -1 over 1 flipped over? 1 over -1, which is still -1. And let's do cotangent. It would just be tangent flipped over, and if tangent is 0 over -1, it'd be -1 over 0. We've got 0 in the denominator, hence we have the undefined quality. Okay, so if we label our quadrantal angles, in this case, what would this be? Well, 0 on x, 1 on y. Here, -1, 0, 270, or 3 pi halves. 0 on x, -1 on y. And of course, if we got to say 2 pi or 360, we're looking at 1 on x, 0 on y. Knowing those, labeling them as x comma y, and then understanding that cosine will correspond to x, and sine will correspond to y, will help me greatly as I construct these quadrantal angles.